Hello everyone. So one of my subscribers have asked me to solve the problems on Centroid. So I'll just explain in a very simple manner how to locate the centroid of a given section or a given figure. Okay. So let us solve problems one by one. Let us take a simple T section first. Okay. So the problem given is to locate the centroid of the T section of the T section. So a simple T section I will take here, that is there is a top flange. Okay, so this top rectangular portion is called as the flange and this is called as the web. Okay, so here the width of the flange is 120 mm and thickness of the flange is given as 20 mm. Finding centroid is very simple. Okay, and this web portion, it is 120 mm, that is the height, and its thickness is 20 mm. Okay, this thickness. So now how to find the centroid? Okay, so first we have to consider the reference axis. Okay, so let us take two reference axes. Okay, so first one here, this is reference axis 1 and another one, this is reference axis 2. So these are the two reference axes. Now first thing what we have to do is, in a centroid problem, first we have to divide the given figure into two simple figures. So now we can divide this T section into two simple rectangular portions. Okay, so let us prepare a tabular column. That is, first one we have to write the component. We have to take one by one. That is, component first rectangular 1 and rectangle 2. Okay, so let us say this as 1 and this as 2. Okay, so component, next column what we have to make is area, that is in mm square. Next we have to find the distance of centroid, that is distance of the centroid of the each area first from 1 axis. Okay, so that is y mm, and next the moment of area, okay, about 1 okay, that is ay mm cube. Okay, so first let us take rectangle 1, okay, so that is the web portion, this one. Now if I draw only this web portion, okay, only this web portion, okay, then its centroid, it is at center. We always know for rectangle it is at b by 2 and d by 2, center of the thickness and center of the height, right? So now distance of this centroid of this web portion or rectangle 1 from this 1 axis, that we have to write. Now first, what is its area? Its thickness is 20 and its height is given as 120. So first its area will be b into d, rectangular portion, that is 20 into 120, that is 2400 mm square. Then for rectangle 2, that is the flange, this portion. Okay, what is area? Again it is a rectangle, that is B into D. Its width is 120 and its thickness is given as 20. So again we will get how much? 2400 mm square. So the total area of T section will be summation of A. It will be 2400 plus 2400. That is 4800 mm square of this entire portion. Okay, entire T section, this is the total area. Now, what is the distance of centroid from the one axis? Okay, so here that is d by 2 I have told just now. So d by 2 means how much it will be? This distance. Total is 120. So this will be how much? 120 by 2, that is 60 mm. So here I will write the same thing, that is 120 by 2. So 60 mm. Distance from axis 1, 1. Now for second rectangle, that is this flange portion, its CG is somewhere located here, right? So for this top flange, it is thickness by 2. Okay, here it is the CG. It will be again, it is B by 2 and D by 2. So here D will be how much? 20. So 20 by 2. So this distance, okay, it is 20 by 2. It will be how much? 10. So that 10 is only till here, that is bottom of the flange portion. Then we want the distance of this CG from the axis 1, 1. So this 10 mm plus this height, that is 120. So that will be 120 plus 20 by 2. So it is totally pure logic. Okay. So if it is located at half of this thickness, means 20 by 2. So here it is located. So it is 10 mm. 10 mm is only till the bottom of the flange, right? So, but we want the distance till this 1, 1 axis. So 120 plus 20 by 2. So 120 plus 20 by 2 means it will be 130. So now AY means product of A and Y. This is A. Okay, this is A and this is Y. So AY, that is 2400 into 60 and this is 2400 into 130. So we have to find product, that is AY. How much we will get? 144,000 and this one we will get 312,000. Okay, so now we have got the AY. Now we have to find summation of AY. Okay, summation of AY, that is adding these two terms, we get 456,000. Okay, now we know that Y bar is nothing but summation of AY by A, right? So we will find the Y bar. Y bar equal to summation of AY, sorry, yes, summation of AY divided by summation of A. So we have got summation of AY as 456,000 divided by summation of A is 4800. So we get Y bar as 95 mm. Okay. So we have got the Y bar value. So I hope all of you understood how to find the Y bar. Now X bar. X bar is simple. That is, it is a symmetrical section, right? Symmetrical means if this is the T section given, if we draw a line at center, then this half is a mirror image of this half, right? This portion is mirror image of this portion. So it will be at this distance, how much it is given? It is given as 120. So it will be 120 by 2. So 120 by 2. It will be 60 mm. So your G of this entire T section is 60 mm, comma 95 mm. That is the location of the centroid G in this T section, somewhere here. Okay, at 60 mm from this end and 95. Okay, 95. So G, it is 60 comma 95. This is how you have to find easily the centroid value. Okay, now this is of the T section. Now let us locate the centroid of I section. Next, locate centroid of the I section. If it is symmetrical I section, then it is different case. If it is asymmetrical, then it is different case. Okay, you will get the different values and the method you have to use is different if it is a symmetrical I section and if it is asymmetrical I section. Okay, now first the top flange is 80 mm and thickness of that top flange is 10 mm and web portion is 15 mm and the bottom flange is width 25 mm and its thickness is 24 mm and height of this web portion is 40 mm. Okay. Now let us again consider the reference axis. Always first step is to consider the reference axis. Okay, so here along this bottom, let this be the reference axis 1 1 and let this be the reference axis 2 2. Okay, now again we have to find x bar y bar values. Okay, so if we draw a center line, okay, about the center of this web portion, again it can be divided into two mirror images, right? So directly we can write the x bar value, that is x bar is equal to 80 by 2, that is 40 mm. Okay, then we have to find the y bar value, that is summation of, as in the previous example what we have done, summation of ay divided by summation of a. Summation of a is the total area of this I section and individually we have to find what is the distance of the centroid of each portion from the axis 1 1. Okay, now let us divide the figure into simple figures. First, component, let us give just a naming for our reference. Component 1, component 2 and this is the third component. Okay, so first component, that is rectangle 1 and area mm square, distance of centroid from the 1 1 axis, that is y in mm. Then next we have to find the moment of area. Okay, that moment of area about 1 1. It is very simple finding centroid. Okay, AY, that is pure logic, we have to remember mm cube. Okay. So for first rectangular component 1, okay, for this one I will write here rectangular component 1 area, that is this one, component 1 area 25 into 24. How much we get? 600 mm square. Then what is for the rectangle 2? For rectangle 2, it is 40 into 15. Again we'll get 600. And rectangle 3, it is 80 into 10. That is 800 mm square. So we have got all three areas. Next we have to find the distance of the centroid for each rectangular portion from the bottom, that is axis 1 1. For this it is located somewhere here. Let us say that as G3. So what is its distance from this axis? That we have to find. So let that be y3. How much it will be? This thickness is 10. So add half of that, that is 10 by 2 plus this distance, that is height of this web is how much? 40 plus this thickness of bottom flange is 24. So y3 will be 24 plus 40 plus 10 by 2, it is how much? 69 mm. Okay. Next, rectangle 2, it is somewhere located here, centroid, right? So let us say this as y2. So y2 will be how much? It is 40 by 2, right? That is, its depth is 40. So it will be 40 by 2 plus 24 is equal to 24 plus 20. That is how much? 44. So 44 mm. Next, for the bottom flange, it is very simple. That is half of 24. That is here. I'll write here y3 is 24 by 2. That is 12 mm. Simple, right? Okay, once you find y1, y2, y3. Sorry, this is not y3. It is y1. Okay. So y1, y2, y3. Then let us write here. It is 24 by 2, that is 12, and for rectangle 2, that is y2, 40 by 2 plus 24, 44, and for rectangle 3, it is y3, that is 10 by 2 plus 40 plus 24 is equal to 69. Now find AY value. AY value means multiply, this is nothing but A. So 600 into 12. That is 7200. Now next is 600 into 44. 600 into 44 is equal to 26400. And next 800 into 69. 800 into 69 is equal to 55200. Now next what we have to do is we have to find the summation of area and summation of AY to find Y bar. Simple. So summation of A is equal to 600 plus 600 plus 800. We get 2000 mm square, and summation of AY equal to, we get 88800. Next, y bar. So y bar, we all know that y bar is equal to summation of ay divided by summation of a. So centroid, finding centroid is made very simple. We have to just divide the given area into simple figures. We have to find the distance of the CG of each simplified figure from the reference axis, and we have to find individual areas and reference axis distances, multiply them, find total area, find summation of ay, then summation of ay by summation of a, we get y bar. So 88,800 divided by 2000, so we get y bar 44.4 mm. So the coordinates of the centroid of given figure are G 40 mm, 44.4 mm. Okay. Next, let me take another example, okay, where we have to find the centroid of a shaded area. Okay, these two were little bit simple examples. Okay, next what they have given is a semicircle is given of diameter 100 mm. Okay, and is cut out from a quarter circle. It is cut out from a quarter circle, okay, of radius 100 mm. Locate the centroid of shaded area. Locate the centroid of shaded area. Okay, so this is the quarter circle and there is a semicircle. This is the shaded area. We have to find centroid of this shaded portion. Okay. So what they have given is the semicircle of diameter 100 mm. So this semicircle diameter is 100 mm. And they have given that the radius is 100 mm of the quarter circle. So this is 100 mm radius. This 100 mm. You have to find centroid of this shaded portion. Now first what we have to understand is we have to take the values for this quarter circle and we have to subtract the values for this semicircle. Okay, this is the quarter circle and semicircle, right? So we have to subtract values for this semicircle, then we will get the centroid of this shaded portion. Okay, that is the logic. First we have to understand this concept, then we can move ahead. Okay, now this is unsymmetrical figure. First that we have to note down, that is it is a unsymmetrical figure. So we have to find both x bar and y bar values. Okay, so first components, then area. We have to, as I said, that we have to take this quarter circle first. Then what we have to find is the distance of centroid from mm and distance of centroid of component, distance of from, that is x. Okay, then we have to find ay and ax. Okay, so first we have to take the quarter circle. So what is the area of quarter circle? Of course we'll get in mm². So pi into radius is given 100. So pi into 100 square by 4. So that is area of the quarter circle. We get 7854 mm². Okay, then this is pi r² by 4. Okay, then let me just extend it little bit. Okay, so this first we are taking for the whole area. Here I have taken the area of this whole quarter circle. Then I am going to deduct the area of this semicircle. Okay, so next what I will write? Deduction. Deduction. In deduction, what I am going to deduct? We have to deduct the area of the semicircle. Okay, semicircle pi r² by 2. Pi r is how much? Diameter is 100, so r is 50. Pi r² by 2. So how much you are getting? 3927. That is, this will be minus. Deduction means this is minus. Next. So here final answer what I have to write? That is summation of A is nothing but 7854 minus 3927. So it is equal to 3927 mm². Now the centroid, that is distance of the centroid of the component from 1 1. Okay, that is y here. One and 2 axis. Okay, so first for this quarter circle, what is its distance from the 1 axis of this quarter circle? Let this be G1 and this be G2. Okay, so that formula you have to remember, that is, it is 0.424 times of r. So here it is given 0.424 times, the radius of quarter circle is 100. So how much you are getting? Simple 42.4. Then let us put a mark here that what we have to deduct. So in deduction for semicircle, what is the formula? Point 424 r. 0.424 into R is 50, so you are getting 21.2. Okay. Then distance of the centroid of component from 2 2, that is distance of this G1 from this. If I just project it, what is this distance? Okay, that is, we can write it as x1. Okay, that x1 value is 0.424 times again R, that is 142.4. And what is the distance of G2 from 2 to axis? This is always, it is here, this distance of G2 from the diametrical axis, it is 0.424 R, but it is always located at half of the diameter. So this distance will be 100 by 2, right? That is D by 2. So 100 by 2. You have to remember where the centroid of each figure is located, whether it is a rectangle, circle, quarter circle or semicircle. And according to the given figure, we have to apply those formulas. Okay. Suppose in a figure what you are taking, it is like this. Okay. Here is the semicircle located. Okay. Here is here the centroid G1. Then here it is axis will be here. Okay, 1 1. Then first you have to find the total distance. Okay, and subtract this 0.424 R from the total distance. Suppose it is x, then x minus 0.424 R will be your value. So that is very important. You have to note where your semicircle or quarter circle is located. Suppose they are asking you to find the centroid of this shaded portion. Okay, so 100 by 2 means it will be 50. Next is AY. AY you are getting, I'll write the answer, 333,009.6, and AX value same. Then AY value, that is 21.2 into 50. Eight three two five 2.4 and 196350.0. Okay, that is, sorry, here that is 78 area is this one, 7854 into 42.4 is this value, and AY is 7854 into 42.4. Then here 3927 into 21.2 is 83252.4, and 3927 into 50, you are getting 196350. Okay, now we have to find summation of AY and summation of AX. That is, you have to subtract this value from this value, that is 333,009.6 minus 83252.4. So how much you are getting? 249757.2. And here 333,009.6 minus 196350.0. So you are getting how much? 136659.6. So once you find summation of AX and summation of AY, then it is very simple. That is, you have to find X bar and Y bar values. So what is the formula? You know that Y bar is summation of AY by summation of A. So summation of AY is 249757.2 divided by summation of A is 3927. So you are getting Y bar value 63.6 mm. Okay. Please mention in the comment section if you are getting the same values, and if you have any doubt you can ask me. Summation of AX is 136659.6 divided by summation of A is 3927. And if you want me to make videos on any other topics, please mention in the comment section. And always, as I have told many times, that All the doubts are always welcome, and I conduct online tutorials. So if you are interested, then you can just mention in the comment section and contact the given number. So the coordinates of the centroid, that is coordinates of the centroid of the shaded area, is 34.8, 63.6 mm. Shaded portion, shaded area G. I hope it is clear. Thank you.